Hello everyone, in this video I'll be solving the problem LIS and LDS. Basically it's the longest increasing subsequence and longest decreasing subsequence. So this question was asked in Codechef contest starter 216. When I was solving this problem, this was third problem, but once I solved it, I don't know, for some reason it went to 4. But I believe this problem is easier than the third one. So yeah, let's read out the problem. You are given a frequency array f of size n and integer an array a of size f1 plus f2 plus till fn is called good if it contains the integer x, exactly fk times. Sorry, fx times. Okay, so x is like from 1 to n. So the score of an array A is defined as minimum of LIS of A, comma LDS of A, where don't worry, this I'm just reading the problem. It is very easy, and I'll be telling you. So where LIS of A is denoted as the longest strictly increasing subsequence of A, and LDS of A is basically denotes the longest strictly decreasing subsequence of A. So overall, good arrays find the maximum possible score. So we need to find the maximum possible score. Okay. Yeah, let's understand inputs. So in the first case we have test cases, and for every test case we have integer n denoted as the frequency array, and yeah, like it's basically size of the frequency array and then the frequencies. So they've given three test cases. In the first test case we have 2 1 1. Let's understand this. So we have 2 1 1 frequencies, as we have 2 comma 1 comma 1. Okay, and n is 3, basically size of the array. This is first example. So before going into test case, let's understand the problem what they're saying. So here what they're saying is we have frequency array of size n. Okay, we have frequency array which is denoted as f and its size is n. Okay, and the elements in the frequency array are f1 f2 up till fn. These are the frequency arrays. Okay, now after that it said this frequency array is good if it contains integer x. So array a of size f1 plus this. So what we'll have to do is we'll have to construct array a of size, its length, or you can say size will be basically frequency. We'll have to sum the we'll have to sum the elements of the frequency array, whatever is the sum. Okay, let's say we sum the elements f2 plus up to on fn. So whatever sum is there, that is the length of the array a. So we'll have to construct array a such that its length is this sum of frequency array, or you can write this also sum as frequency array as fi. I is from 1 to n. I am taking one best index. Okay, we'll have to construct this. So when we are constructing this array, now so this array is called good, if it contains exactly integer x, okay, fx times. So this array is called good. Don't worry, this problem looks weird, but the idea is very simple. So just bear with me for 2-3 minutes just to make understand you. So this array is called good if the elements in this, right, the elements in this will be, let's say, element x we have, and that has to be frequency of x times, which means this x is going to be from 1 to n, whatever is the size of the frequency array, so it's n. So we will have to take the elements 1 2 3 up till n, and whatever is the frequency, I am taking one base index, it is 1 2 up to so on n. So here whenever x is 1, so uh, its frequency is f1. So in the array A, 1 has to be f1 times, right? After so all f1 times, right? This is the array A. Similarly, 2, it has to be f2 times. This is the thing that is saying. Only if this happens, then the array A is called good. Okay, so the score of array is defined as a minimum of longest increasing subsequence of A, longest decreasing subsequence of B. Uh, yeah, so overall all good arrays find the maximum possible score. So you don't have to focus on this good array, because from the question whatever array whatever frequency they have given, so you can make array as good, right? So now let's try to construct array A. So when you want to construct array A, this is one best indexing. If you take, so here x is 1, like this is 1, so its frequency is 2, so 1 has to be 2 times. Now x is 2 here, okay, it's like index 2, so its frequency is 1, 2 is 1 time, and 3 is also 1 time. So this is the array A, okay, and it is good because according to definition it is good, and the length of array is the sum of frequency of this, which is going to be 2 plus 1 plus 1, which is 4. So length is 1 2 3 4, right? So among this what they're saying is you will have to find the maximum possible score. Yeah, we'll have to find the maximum possible score, and which is given by, score is basically given by minimum of longest increasing subsequence of A, comma longest decreasing subsequence of A. Okay, so now you have made array A this way, but if you want to find longest, and it is strictly not equal to, it is strictly increasing. My bad, when I was mentioning increasing, so it is strictly increasing. So one subsequence you can take is this, it is increasing 1 2 3, right? But okay, so here the score will be minimum of, in this array the score is like longest increasing subsequence is 3, but decreasing you don't have any, it is 0. So minimum of these two is 0, the score is 0 in this case. But what if I make some arrangements in this? If I make this array to be this way, 1 2 1 3, right? When I make this way, now longest increasing is to be like, if this is the case or this is the case, so its length is 2 only, and longest decreasing will be 2 and 1, so it is decreasing, right? So here the score will be minimum of longest increasing, as we can see either it is 1 2 or it is 1 3, so its length is 2. Decreasing, if you see, we have only 1 2 comma 1, so it is 2, so score is 2. So which is better, score 0 or 2? 2 is better. So let's again try to modify this and try to find. So when you modify the array to be 1 2 3 and 1 in this way, now score is going to be minimum of longest increasing subsequence. You can take 1 2 3 as the longest increasing subsequence, right? So whose length is 3, but decreasing is 3 and 1 only, so its length is 2, the score is 2. So this is one of the optimal arrangement, and its score is 2, and for this answer is 2 only. So how do we solve this problem is the question now. So during contest I came up with an idea. Since we want our score is dependent on longest increasing subsequence and longest decreasing subsequence both, so the score has to be minimum. In order to score has to be minimum, your both LIS and LDS both has to be maximum, right? Because if you make one either increasing or either decreasing as maximum, the other to be minimum, since your score depends on minimum of these two, so your score will be minimum. Understanding, right? So let me tell one more time. Your score has to be maximum. In order to your score has to be maximum, so what you have to do is we have to find the longest increasing and longest increasing decreasing, both has to be maximum. When both are maximum, in that case only minimum of that will be your answer. If you make one longest increasing either or longest decreasing as minimum and other as maximum and other as minimum, so in that case your score is like minimum of these two, right? So your score will be less. So whenever you are constructing array A, you'll have to keep in mind both as longest increasing and longest decreasing. So this point is clear, right? So now let's understand. So now over here main agenda is we'll have to find the longest increasing or longest decreasing. Okay. So let's take some examples and see. We have two. Okay. So let me take some other example, ns4, or let me take ns5, and the frequency array let me take as 1 2 2 1 2. Okay, I want to take this way. So here one base indexing. See, what I want to do is actually I want to make an array in such a way that we have both longest increasing and longest decreasing, right? So okay, let me first write the array and then we'll think of the order. So 1 is 1 time, 2 is 2 times, 3 is also 2 times, 4 is 1 time, 5 is 2 times. Right? So what I will try to make is I will put 2 at this position, since we have two 2's, and one more at the end I'll put it. Okay, this is smallest whose frequency is more than 1. Okay, 1 also is there, that is smallest, but its frequency is only 1 time, but 2 is 2 times. So I can put here and here. Since 1 is only 1 time or 4 is only 1 time, so these elements can only be put either in the increasing side or in the decreasing side, right? so so these elements are not of much importance. The elements whose frequency is greater than or equals to 2, those elements are important, because those are the elements which will be contributing to longest increasing subsequence and longest decreasing subsequence. So now we have 3 2 times. Let me try to put here. Let me try to put here. So you are understanding that what is happening. Here I am building longest increasing subsequence, and here I am building longest decreasing subsequence. 5 is 2 times, right? Now the left elements are 1 comma 4. You can put it here, there's no issue. Okay. So you can put it here, or you can put in this way also. A is equal to, let's say you can put 1 here, and then you can put 4 at this position also, 5 this position also. But the main thing is 2 3 5 5 3 2. These are the elements who is contributing to the answer. Okay, because your score depends on both longest increasing and decreasing. Again I am repeating the same points multiple times, because you'll have to understand that it is very important. Okay, so here if you see longest increasing subsequence, in this case you have 1 2 3 4 5, which is whose length is 5. Okay. And if you want to see decreasing, this you can't count because these are equal, they are strictly decreasing, so it is 5 3 2. Okay, so its length is 3, so minimum of these two is 3, so your score is going to be 3, right? So you take multiple examples, and you can take frequencies other way around also. Other way around meaning, let me take one more example. N as 6 something, frequency is to be 3 1 2 4 1 2. So which means 1 has occurred 3 times, 2 has occurred 1 time, 3 has occurred 2 times, 4 has occurred 4 times, right? 5 has occurred 1 time, 6 has occurred 2 times. So meaning of this is this. Now you'll have to make arrangement in order to make score as maximum. So what I'll try to do is this, the element 2 and the element 5, these two have the frequency just 1, so they are not actually contributing to the answer. They will contribute to the answer only in single case, either LIS or LDS, not both. So or in order to make our score as maximum, we have to concentrate on the both. So what I'll try to do is, now we have three, 1 is 3 times, so 1 I'll put here, 1 more I'll put here, but one more one, whatever is that I'll make it separate. I mean, I'll let me don't put it, because if you put 1 here, this is not contributing to LIS or LDS, because elements are equal. So here frequency 2 is important, right? 2 is only 1 times, so let me put 2 aside. 3 is 2 times, let me put 3 here, 3 here. So LIS 2 here, and LDS also 2. 4 are 4 times. Let me put 1 time here, other time here. I will not be putting here because it is not contributing to LIS. Instead, what they are doing is basically it's not of use. So let me just put it here, 2 times 4. Now 5 is 1 time, so I'll be using later. 6 is 2 times. So now you have 4 length LIS and LDS, right? Okay, so yeah, this is the thing now. Now you'll have to understand. See, we have 1 2 4 5. Now one, what I can do is I can put in somewhere. So if I put in here, 1 I'm putting it here, 1 is gone. 2 is there, let me put it here, 2 is gone. 4 is there, let me put it here, 4 is also gone. Then we have 5, right? 4 we had 2 times, so I can put in one more time here or there, doesn't matter, right? And then I can put in 5 at this position, 6 comma 5. So basically why I'm putting 5 here, why not here? Because whatever remaining elements we have, right? So those remaining elements like the whose frequency is 1, right? These elements, since they are 2, so we can, and these two are unique elements. I mean, it is like 2 and this is 5, x is equal to 2, x is equal to 5. So since there are 2, and in order to make LIS to be maximum and LDS to be maximum, 1 2 can be placed here. So you'll have to place in such a way that it is making LIS, right? If you put it here, your LIS is going to be 1 2 3 4 6, and one more whatever is remaining, you put it in LDS. You had 6 4 3 1, right? So if you put 6 5 4 3 1, so it is increasing. So the basic thing is the frequency whose frequency is 1, you will have to count that. So let me put 1 f whose frequency is 1, okay, and then whose frequency is greater than 1. So those elements will have to choose. So those the elements whose frequency are greater than 1, like 2 2 3 or 4, so these elements can be put in here and here. But the unique element frequency whatever we have, these elements, half of we can put it here and here, right? Understood? Since it's like 2 here, so we are putting 1 1. What if there were 3 elements of frequency 1? So in that case you can put 2 here and 1 here, or 2 here or 1 here, because you can't put since we have the odd number, so you'll have to mix in such a way that half goes here and then half minus 1 or something like that goes here. So both LIS and LDS are maximum. So I think I've explained the problem. Uh, so if you try to understand the pseudo code, it is going to be this way. So first we need to find the one frequency and more than one frequency. The elements having one frequency and more than one frequency. So as we have seen, your score is going to be minimum of LIS, comma LDS. So your LIS was more frequency, right? More than one frequency plus it is going to be 1 by 2, one frequency by 2. You understood this, right? Because I was placing the elements which have more than one frequency in both the sides, so they were contributing to the LIS and LDS both. So in the LDS also it is going to be more frequency, more than one frequency plus. So more than one frequency we are contributing both left and right hand side, and the frequency having one element half we are placing on the LIS, and the one minus, sorry, one frequency, the total frequency, one frequency if you count it as k times, so it is going to be k minus k by 2, right? So total we had k of one frequency, k by 2 is taken at this position, let me write k only. So total we had k, so k minus k by 2 will take here, and then score is going to be minimum. So I think you understood. Let's try to code it up. So we have test cases. Test cases I've taken at this position. For every test case we have integer n. Okay, we have integer n, size of the frequency. Then we have frequency vector. Okay. So we have frequency values. So we are taking all the frequency values. Now we'll take one, one frequency elements having frequency 1, and then more than one frequency elements, which is again initially 0. Now we'll have to count if frequency of I element is 1, then we are going to increase here. Else definitely, since in the question they've said the frequencies has to be non-negative here, right? It is from 1 to n. If it is not 1, then obviously it is more than 1, so it will go to else condition. So it is going to be more than one frequency. Now longest increasing sequence is going to be one frequency plus more than one frequency by 2, right? And then longest decreasing subsequence, it is going to be one frequency plus more than one frequency minus more than one frequency by 2, right? At the end we'll have to print the score, and your score is going to be minimum of LS, LDS. Print the score. I think you guys understood, right? So the main thing was like understanding the problem. What is wrong? More than one frequency by 2. Okay. Let me check. We are putting all the frequency. More than one frequency we are increasing. Longest increasing will be sorry, my bad. It is not one frequency, it is more than one, right? and here it is one frequency. I did it other way. So yeah, let's try to run it. Okay, again it is showing 0. Just give me a second. Frequencies I'm taking input, and then in both LIS and LDS more than one frequency will go, and yeah, one frequency is going to be here. Let me see what I had done. So I had basically taken, I've not taken vector, I had taken directly one and more than one, and my answer was directly 1 by 2 comma 1 minus 1 by 2. So it should have been minimum rate. So I've not put in here any minimum or something like that. Okay, let me try to write this way only. It is getting passed. Let's say one frequency is 3, 3 by 2 is going to be 1. Just give me a second, let me try to see the problem. Maximum possible score. Because score is defined as minimum of this thing and overall good arrays. Maximum possible this thing. So let me try this right. Yeah, it is getting passed. Let's try to submit and see. Context problem is not available for accepting solutions. So right now they are not able to accept. But the thing is, I've understood here. Always the answer is going to be more than one frequency plus one frequency minus one frequency by 2. So that's why whenever I put in this thing, right, LIS comma LDS, so always score will be evaluated to, I think, LDS value. Let me try to check. what value will be evaluated. Basically I'm checking in this score which value is going to be put in. Use comma separated, meaning the comma operator left to right, but the result of entire expression is the value of the last expression. That's what the score will be. LDS only. Longest decreasing subsequence. So yeah, score is going to be this thing, but we'll have to prove it how. Let's try to think. Let me try to put it this way. So 1 1 will be here, right? This is array A. 1 2 3, 2 is going to be here, then we have 3, it is going to be here. So your answer is always what the thing is. So as you can see here, this is LIS and this is also LDS. So basically these three now here is contributing both the side, left hand side and right hand side. Okay. So in this case both score is going to be 3, but what if do I this way? LIS is basically more than one frequency is 2 plus 1 frequency by 2, this is going to be 0, and LDS is going to be more than one frequency plus 1 frequency minus 1 by 2, which is 0. So this is going to be 3. So minimum of these two is going to be 2. Okay, so I think these three whatever we have we are missing something. Yeah, like this 3 is contributing both hand side, left hand side and right hand side. So in the similar way there will be elements. Let's try to take the other example. Let's take frequency as 2 comma 1 comma 2. Now our array is going to be 1 comma 1 here, 3 comma 3 here, and then 2 we have only one time. Let me put it here. So in this case Li is 3, but your LDS is going to be, if you take 2 and 1, or if you take 3 and 1, so let me cross check if the question is saying longest strictly increasing, longest strictly decreasing. In both the case it has to be longest increasing or longest decreasing. I don't know, like some in contest it got accepted, but yeah, when I'm explaining I'm getting problem now. So and what if I put 2 here? Okay, yeah, there's a magic. If I put 2 here, okay, understood. If I put 2 here, what is happening? 1, 2 and 3 is contributing in LIS, which is 3, and 3 to 1 is contributing to LDS as well, which is 3, and your score is both minimum of LIS and LDS, which is 3. Okay, understood. So it's like we can make arrangements in such a way that uh, there will be more than one elements, right? Even uh, yeah, if there are more than one elements, even if it is not there, like we have one and one, what if the more than one elements is not there? We had frequencies 1 1 1 only. So in that case also, what would happen is we had 1 2 and 3, so you can put 1 2 and 3. Now LIS is 3, LDS is just 1, or you can put 1 3 2, so LDS is 2, LIS is also 2, right? So what we can do is the one frequency whatever we have, you can put half this side and half this side, and if there are, let's say, 3 times 1, or 1 time only one frequency, so that element is contributing to both left and right. So that's why in the contest when I was writing the formula, LDS as more than one frequency, more than one frequency, plus one frequency minus one frequency by 2, so it was working. So this whatever extra that we have, it is contributing to both left and right. So understood, so it is correct only. So it's just a problem statement that we had to understand. So always your answer is going to be more than one frequency plus 1 minus one frequency by 2. If one frequency is even, then it is divided equally. If it is odd, then if it is odd, then the extra one is taken in the LDS only, which is basically score. So yeah, this is going to pass. Let's try to submit the code. Okay, here it is not accepting, but I think I've showed you the submission, right? So as you can see, um, this is getting passed. So um, here more than one is common only, but in this case, as I showed you on the chat GPT, it was showing like the left hand side value is taken finally, so this value is taken finally, so this is our answer. So I think you guys have understood. If you did not, so you can comment and I'll try to help you out. But if you have gone through video from starting, then I think you guys have understood like how I approached, and then what made me confusion to think, and then we finally solved it. So yeah, thank you guys for watching the video.